Okay, thank you, Wim, for the presentation. Thank you, Andy, actually, for the keynote. Well, in my case, good morning to everyone, but probably also good afternoon and good evening to the others worldwide. I'm Umberto Berardi. I graduated, studied the PhD in Polytechnic School of Bari, and nowadays actually I'm in Worcester Polytechnic Institute, not too far from Boston, actually something like 20 miles from Boston. So here is almost 8 o'clock in the morning. First of all, the outline of the presentation for this morning meeting, I will start with a brief introduction to the energy modeling and to the energy problem of cities worldwide. I will actually move to the energy saving opportunities that we have nowadays for cities, and I will focus on medium-sized and very huge cities. So I will skip from actually small cities in my presentation. The third part of the presentation will be dedicated to a comparison of sustainability assessment systems actually that we have for the city level. And I will consider also the district and neighborhood levels. Then I will move to considering few of the characteristics that certified communities and certified cities have nowadays, and then finally a few trends and actually future steps in the sustainability assessment of cities related with the energy consumption activities. So first of all, I think I don't want to spend too much time about the introduction, but we know the problem. We know that the energy consumption is increasing, and it's increasing not only because the Western and the North America have still actually a huge amount of energy consumed, but also because in the Southeast countries and in developing countries, especially in China and in the South Africa region and in India, we are actually facing on a very huge amount of increasing. And this actually is supposed to become more and more critical in the next 20 years. Together with this, we know that most of the population is moving to cities. We already knew that in Europe, for example, most of 70% of people is living in cities. And unfortunately, from this picture, we can actually have an idea of the relationship between the urbanization level of a country together with the footprint of that country. And we see that actually the more green is the point, actually the bigger is the footprint of that country, which means probably cities are not really the best option in terms of sustainability, at least from an environmental point of view. And as I said, actually, we are moving to a community in the world that is more or less living in cities. In 2008, probably there was the challenge, so the point in which more than half of the people was actually living in the cities, and we know that especially because all the population in developing countries is moving to cities whereas actually has a lot of opportunity in terms of economy, but it's actually creating also a lot of problems in terms of sustainability of those cities. And in principle, it's quite impressive if we consider the energy consumption together with the dimension of the cities, because we are moving from a community in which cities were middle-sized and then became bigger and bigger and bigger, and nowadays we're actually facing with tens of millions in cities. And this is just a projector for the next 15 years, and we can see actually the amount of huge cities we will have worldwide. So with this, I actually stop my introduction because I want to move to the main part of my presentation, which is related with the energy opportunity we face in cities, in order to reduce this picture. This picture is showing us, okay, a lot of developing is actually producing a lot of CO2 emission. So in principle, I will start from a very beginning point from the Factor 4 book. It's a book of 15 years ago in which we faced the problem that we have to move our society in a way that we can double the wealth and that'll be a resource. A few years ago, we are actually moving from the Factor 4 to the Factor 10. Let's say, in principle, we have to try to move our cities and our society in a way that we became 10 times more efficient. And I think that is a big opportunity for cities. In principle, I will show you, for example, this very challenge figure that I took from a paper of Carlo Ratti. It just published a few years ago. Carlo Ratti is actually one of my professors here in MIT. He's actually director of the Sensible City Lab, And in principle, he was saying, moving from previous studies, that the energy performance in cities has actually a factor 4, a factor 10 opportunity. Let's say the building itself is able to save at least half, or we'll say probably more, of the energy consumption. But we have to consider the energy saving opportunities with opportunities related with the occupant behavior that can be actually responsible for another factor 2, together with the systems opportunity. So integrating more buildings together, as Andy was saying, in order to share opportunities, together with the fact that the morphology of the cities, so the urban context and the urban shape, can actually have a very huge impact. Want to stress this actually type of figure because I think probably nowadays there is actually huge pressure about building energy saving efficiency and technologies, but there is not enough pressure on the other sides. We spoke a bit about occupants, and we soon realized a few years ago of the redundant effect. So we save energy in buildings and then people start consuming more energy. But I think what is still missing at the energy simulation, the energy actually speech in cities, is actually an interconnection of the several dimensions. Here you see the energy models that have been used in cities. In principle, we can have energy-based models, economic models, energy environmental models, and morphological models. Each one of these type of energy models for cities is more or less related with the previous dimensions. Let's say an energy-based model is more or less considering the behavior of the people. An economic actually model is considering the huge possibilities we have at the country level if we considering the energy policies with actually the possible energy saving. The energy environmental models are more technologically related. They actually are trying to assess the energy consumption and the environmental impact we have in cities. And finally, the morphological models are models that are considering the shape of a city in terms of the relationships between streets, buildings, open space, closed space, in a way that we can influence the shades of buildings together with the ventilation, the wind in buildings, and so on. Now, nowadays, actually, on the column on the right of the screen, you can see a few examples. For example, there is actually a huge amount of energy-based models because we realized that, for example, with Energy Plus or Design Builder Simulation, we don't really know exactly the profile of the energy consumption from people. And I want to tell you and to share with the others that in US nowadays they have actually building energy research benchmark definition, and they are actually using this kind of profile that is quite important because it's giving us the time with a time step of 1 hour the profile for several activities of American people. Obviously, my idea is that this kind of profile can be compared with the behaviors in other actually cities and in other countries. So we know something about the energy-based, but it's still a micro-level model. Let's say we simulate one single building and we study the dynamical consumption of that building, which means we don't really have an idea of the way in which a city is actually working as a whole community. Together with this, the other actually kind of more macroscopic approach to the energy model in cities, let's say the economic and the energy environmental approach, are probably too upscale. They are able to consider the final output of a city, as probably Andy was saying, but they are not able to simulate the behavior of the people, so they don't really pick actually a big opportunity that we have to change the consumption of the people before it's happening. Let's say what people are doing, we have to move people through a more sustainable actually path. So in some way, I think nowadays the real challenge we have as researchers is to try to connect at least these different models because they don't really communicate each other quite a lot. And the idea, and my idea, is that we have to move from a research point of view trying simulation models that are able to connect different models, and probably this can happen also outside university. It has to happen outside the academia in order to share these kind of models with all the stakeholders, including policymakers and people worldwide. Just to give you an idea, another actually picture taken from the Sensible City Lab in MIT here, and this is actually the picture of the MIT campus consumption has just been published on an energy buildings issue, and you can find actually the relationship with the energy consumption of buildings together with the number of people who are populating the different buildings and the kind of actually activities they were doing. These kind of models that are not really common are actually using, for example, in this case, a Wi-Fi network, and we were able to assess the energy consumption of different buildings from the number of people connecting to the Wi-Fi network of MIT. Let's say this kind of models in which we do not considering the energy dynamic without the behavior of the people, without the energy shape of the community, they should be probably be pushed in the near future, because according to me those are actually the challenge. And I want to show you also a good study is actually happening in Bari, in the Polytechnic School of Bari, regarding the urban morphology. In principle, an historical center, so here we are facing on the problem of retrofitting of an historical center has been modeled from an energy point of view, and we were able to discuss energy strategies and energy policy at actually the urban level. And this is still an unpublished work, but in principle the idea is that we have to consider urban morphology together with behavior of people and activities that are happening in the building. And I think really that is quite important to show the opportunities cities are facing in comparison with the energy efficiency together with their smartness. Because especially in Europe nowadays we have actually a huge pressure for the smartness of cities. Every city wants to become a smart city, but we don't really know what is a smart city. So we need to move and probably join the strength and the activities of the smartness movement with the energy efficient movements in a way that can become more sustainable. Now, it's probably not easy to define what a sustainable city is, and I can tell you I faced quite a lot this problem with my colleagues, because in principle, sustainability can be assessed, but is still an undefined, let's say, concept at the city level. We have to sure be consequent of the identification, predicting, and evaluating of the potential impacts at the city level. So last year I published a paper in which I compared different sustainability assessment systems at building level. Now, if we move to the sustainability assessment at the city level, we discovered that we don't really have this momentum, this actually strength and attention for the city level. In principle, we know we have LEED and the neighbors, we have the BREEAM standard for community, we have the CASHB, now also for cities. But in general, there is actually a poor attention for the sustainability assessment of cities. And this is a pity because we are lacking actually a momentum in order to consider the energy consumption at a larger scale. Now, what I did actually for this presentation is that I compared the ways that different systems for communities, so BREEAM, CASHB, and LEED for community, are giving to different categories. Let's say I use the criteria and divide the criteria in different categories related with sustainable land, location, transportation, energy, ecology, economy, and well-being, and I look at the total percentage over the total actually assessment. Now, if we look at the energy and resource consumption, it's probably quite easy to realize that the energy attention nowadays cities are receiving in terms of sustainability assessment is quite low. We are actually below the 15%, and that is probably a pity. Together with this, I want to show you probably a useful and quite interesting new sustainability assessment system that has been developed last month. Is the STAR community rating systems. For people who doesn't know it, is actually being developed by the GBC together with the ICLEI, together with other American associations, and it's quite promising in terms that has been produced as a collaboration worldwide. In principle, if we look at this new sustainability assessment system, we realize that over the 600 points that are possible in the system, or let's say in the 70 under points, if we also consider the innovation part, the climate and energy measures is only actually 100 points. And then if we consider the points within the system, we realize actually the pressure and the attention to the energy actually performance of the cities is not so strong. Let's say the resource efficient use in building is only 15 points over 700. So it's actually few percent points. And this actually allow me to make some conclusion about sustainability rating systems for cities in relationship to the energy consumption of the cities. So for sure, they are characterized nowadays by an unscientific selection of the criteria, and they are characterized by several limits. But I want to share a few definitions that have been recently proposed by Salat from Paris. And in principle, he said actually new sustainability assessment systems are lacking the really energy opportunities we have in cities because they don't really put too much attention to the energy consumption. And probably this is related to the fact that we are not still able to have energy models that are able to simulate actually the behavior of a cities. What I did actually was to compare actually the performance of different communities. So I use a set of 70 different communities, more or less spread around the U.S., and say, okay, let's see the performance as certified communities in order to understand what a sustainable community is actually doing. Let's say, what are the characteristics that we face in a certified lead community. And I don't want to stress on the smart location and neighborhood pattern design criteria, but I want to stress probably on the next slide in which I select and I show you the results related with the green construction and technology. Now, if we see this slide, we realize, for example, that over the total amount of possible points, the earned points are very low, which means most of the certified LEED communities are not behaving in a good way in terms of the energy-related performance in the categories of green construction and technology. And this is quite important if we consider, for example, the percentage and the relationship, the ratio between the earned points over the total available points for different criteria related with the energy. And we really realize, for example, that if this system is giving 1 point for solar orientation of the community, then the average of the communities have a result of 0.3, which means actually 67% of the communities that have been included in this sample have not an attention to the morphology of the buildings, which is a pity. Now, these two studies still unpublished. I'm actually finalizing. Hopefully, I will be able to submit in 1 or 2 months, and actually we'll be able to show more things actually in the next future. But I want to conclude with few trends in sustainability assessments of city related with the energy. First of all, we have to face the problem that energy assessment at building level is not enough. So we have to move to a larger scale. We need to do that. But to do that, we have to consider that externalities, behavioral influence, and long-term effects need new models. We cannot do that with a dynamical, precise model that is able to focus on a very small activity of a guy in a building, together with the fact that we cannot do it at a macroscopic level, just dividing the energy consumption of a city with the number of the citizens, especially because those data are not available, and especially because a city is a much more complex, actually, example. We don't really know who are the citizens, how many they are, if we consider also tourism and other actually opportunities. Then actually I want to conclude this presentation saying you, okay, nowadays multi-criteria system lack or neglect actually energy criteria in a good way, together with the fact that they are not able to integrate the energy consumption with economic and social implication of energy opportunities. So we need to reconnect those actually activities And I won't actually also be happy if we were able in the near future to balance the complex of energy consumption models together with the simplicity. Because what we are still lacking is actually an implication for the policies and for the mayors. We need to become actually we more familiar to them, and our actually results have to be shared with them. We are actually doing that in the Italian case study I showed you from the Polytechnic School of Bari, because that was actually the final goal of the energy simulation. And I think actually we have to create a momentum in order to press again the energy attention at the city level. And in this idea, probably institutions like ICLEI or other institutions are quite important for us, because most of the agencies for sustainability assessments have actually a real market focus, so they don't really are interested into the city level. But at actually the city level, we have the biggest opportunity in order to go through the factor 10 I just showed you. Well, this is just a brief actually list of reference together with the presentation, and I think I used more or less the 10 minutes I had. So I thank you for the attention, and I'm available for future questions. Thank you.